Hello everyone, let's continue our discussion for JEE Mains 2021 August 26 morning paper previous year question. Concept explanation with solution. For more videos, you can visit at the rate www.sapienseducation.com. Let's move to the question. It's given you that an amplitude modulated wave is given with a equation like this way. So tan into 1 plus this thing. So cos omega t. So omega m will be the modulating frequency, that is 12560. They have directly given you this will be equals to 2 pi into fm will be equals to 12560. So fm modulated frequency will be 12560 divided by 2 pi. 1250 into 2 into pi is 3.14. Is 26280. So it looks like it's the same number. 2000. So you have to mark as 2000. But he asks you in kilohertz, so the answer will be 2.00 kilohertz. The next question is short magnetic dipoles of magnetic moment M1 and M2. So this is M1 and this is M2. Having magnetic moment already given are placed at point P and P. The distance between OP is 1 centimeter. The torque experienced by the magnetic moment M2 due to the presence of M1 is. The torque experienced by a magnetic dipole in an external magnetic field is given as M cross B. So you are asking for a torque experienced by 2. So that will be the magnetic moment of 2 cross this because of 1. That means the responsible magnetic field is of. And you can also say that the magnet you need to calculate magnetic field because of 1 at 2, and this 2 point is at an equatorial position of 1. It is at an equatorial position of 1. So the magnetic field at equatorial position, the formula for magnetic field at an equatorial position is given as mu naught by 4 pi m by rq, and the distance between them is 1. So 1q. So this will be the magnetic field B1. So here you can say that the magnetic field B1 will be equal to, because it is an equatorial position, will be equal to mu naught by 4 pi m by 1, and the magnetic field will be opposite to the magnetic moment, so it will be like an downward direction. So you have to calculate the cross product, so we can easily see that. But before that, the magnetic moment is m2, so you have to calculate m2 into b1. So we can directly use m2 b1 sine theta. And what's the angle between m2 and b1? That is 90 degree. And sine 90 is 1. So sine 90 is 1. So m2 into b1 is the answer. And m2 is 1. M1 is also 1. So mu naught by 4 pi. For this is M1. That is also 1. So everything becomes 1. So it becomes mu naught by 4 pi. That's the value of 10 raised to the power minus 7. And torque is Newton meter. So the answer will be 1.00 will be the answer, because the same number came into the picture. Move to the next question. Two traveling waves produces a standing wave. The equation is given as y is equals to 1 mm cos 1.57. We are not taking the units here. X and sine 780.5 t. So the node closest to the origin. Node is a position of 0. Node is a position of 0 amplitude. So the amplitude becomes 0. This represents an oscillating function, that it is oscillating with respect to time. So if I will talk about a standing wave, so in this wave, the each and every particle is oscillating with a certain oscillating with the same frequency up and down. So this sine omega t is representing about this oscillation part, while this complete represents an amplitude of a standing wave. That means each particle amplitude. So this will have a different amplitude, this will have a different amplitude, and so on. And you want a node. Node means the amplitude should be, you need to calculate a node, and the node means the amplitude should be 0. The amplitude should be 0 means this cos 1.75x must be equals to 0. Cos is 0 at 90 degrees, so we can say that 1.57x is equals to 90 degree, but in radian it can be written as pi by 2. So in radian, it can also be written as pi by 2. So we will solve this, but make sure that this is in the unit as 1.57 per centimeter. So you are getting the answer in centimeter. So this 1.3.14 by 2 is also 1.75. So x is 1 centimeter will be the answer. And he asked for the answer in centimeter. So answer again will be 1.00. And this will be the question. Next, move to the next question. A light is passed through a double slit experiment is observed on a screen. So there is a Young's double slit experiment. Just take a double slit experiment and there will be on a screen. Is observed on a screen that is 1.5 meter away. The separation between the slits is given as zero point 0.3 meter. The first violet, so first we have used the violet fringe. So the first violet fringe are formed at 1 mm from the central line. So the first violet fringe is at 2 mm from the central line. This is the first violet. And the first red is formed at 3.5 mm from the central line. So the first red is came out to be equal at a distance of 3.5. So what's the difference in the wavelength of these two colors? So let's try to solve this question. So we already know the position of maximas. So maxima's position is given as, the positions of maxima will be given as L lambda d by d. So we are talking about the first position for violet color is 2 mm or n into, first they are talking about a lambda of violet, that is lambda 1 into d by d. That's the equation number first. In the second case for a red it is 3.5 mm, that should be equals to lambda 2 d by d. But the problem is here, if you will divide, you will get the ratio of lambda 1 minus lambda 2. But you have to calculate the value for lambda 1 minus lambda 2. That means you need a difference in wavelength. So just subtract them. The answer will be 1.5 mm. 2 minus 1. Second equation minus 1 is 3.5 minus 2 is 1.51. Lambda 2 minus lambda 1 into capital D by small d. So lambda 2 minus lambda 1 is equals to 1.5 mm into small d is itself is 0.3 mm divided by capital D itself is 1.5 meters. 1.5 is cancelled. This millimeter will make it 10 to the power minus 6. You need the answer in nanometers. So you have to multiply by 1000. So it will already become 300 nanometer will be the. So the answer for this is 300.0. Next question. Given you a badminton racket with lengths are also given you. You have to calculate if the mass of a linear and circular portion of badmintons are same. Okay. The mass of the threads is negligible. The moment of inertia of a racket about an axis perpendicular to the angle and in a plane at a distance of r by 2. This exists about now. How we can solve this? So we have to calculate individually. We will calculate the moment of inertia of these two bodies along the same axis and we will add them. So first we will calculate for this one, this handle part. What will be the moment of inertia of this handle? So we already know the moment of inertia of this handle will be equals to. So first of all, we have to understand we can only apply parallel axis theorem. And in parallel axis theorem, we should make sure that one axis should be a centroidal axis. Otherwise, we can not solve it. We cannot solve it. We have to apply one of the axis as a centroidal axis only. So although we know, so we have to get the moment of inertia of this rod about its center of mass, and then we have to get at this point, that is our axis as A, where we wish to calculate. The distance between this is 6 hours, this is zero point 0.5 hours, and the center will be nearly at 3 hours, so this will become 2.5 hours. Because this total is 6 hours, the center will be at. So the moment of, according to parallel axis theorem, the moment of inertia about an axis A will be equals to moment of inertia about center of mass plus m into d square, but make sure one should be in center. The distance between these two axes is 2.5. So moment of inertia of any body about center of mass is given as ml square by about of a rod about the center of mass axis is given as ml square by 12. The mass is m and the length of this rod is 6r square by 12 plus m. We have to shift this to a 2.5 r the whole square. So mr square is common. This will become 6 square 36 plus 12 is by 12 is 3 plus 2.5 square is 4.45. 2.5 square is 6.25. This will become mr square into 9.25 will be the number. That's the first part. Second, we have to calculate for this racket part, that will be the circular part, and this will be considered as a ring. So this is a ring because other will be a material. So ring ka moment of inertia. The ring ka moment of inertia you already know about its diametrical axis. So the moment of inertia about diametrical axis, and this will be definitely pass through center of mass, and we have to shift it to a distance of a axis, and a from this its center is r plus. So basically center is 7r for n or but zero point 0.5 minus, that means 6.5. Basically you can see that this is from here to here, this is actually equals to 6.5. Then again you can apply the moment of inertia as the moment of inertia about a because of this radical factors, moment of center of mass is m. The radius for this is, we should have to make sure that it is given as r itself. So mr square by 2. So it's about diameter, that's why mr square by 2 plus m into the shift here is 6.5 the whole square. This will be 6.5 r the whole square. So we took mr square as common, so this will become zero point 0.5 plus 6.5 whole square will be equals to 42.25 r. This will become mr square plus 47.25, the second one, and just add both of them and you can get the, sorry, 42.75, and if you add both of them you will get the answer as mr square 0.75 plus 1 is 1, this is 10, so this will be into 52. 52 mr square is the answer, and you need just a number, so you will mark as 52.0. Let's move to the next question. Thank you for watching. Please subscribe for more content to our YouTube channel, that will be sapienseducation.com, and you can visit us at Meta, Facebook as well as Instagram also. For more such videos, you should visit our official website as at the rate www.sapienseducation.com. Call or WhatsApp at the number 8197 767 637. So hope for your well-being. Have a nice day. Take care. Keep smiling. Take care.